able to think backwards? You get them? Okay. So you think, all right, well, it started off with log base something. Well, the base is where we start when we snail shell. So it would be 11 to the third, snail shelling, equals 1,331. And now if it gets crammed, like mine did, it's a test. You're going to want to erase it. And make sure your base is a subscript. So that it feels like it should, you know. So you might have to kind of do a practice one space-wise and then either erase or write it over again once you know what that spacing is. So this one would say logarithm base what? 5. What am I going to put over here? -3. And right here. And again, that's kind of cramped. I move my equals over a little bit. Like so. So unsnail shell. Kind of think backwards about that snail shelling process. And then we get to this one. What fun this will be. It is. What's the base? X equals back here. Now, it looks kind of bald sitting there without parentheses. You wouldn't need the parentheses, but it kind of drives me nuts too. That would show that those should stay grouped together since they were grouped together in what we originally had right there. All right, unsnail shelling. Are you okay with that one? Yeah, because remember, the fancy name for that is exponentiating. And so when they talk about this one, they're going to say, you know, put it back in a logarithmic form because the inverse of exponentiating is logarithmic form. All righty, condensing. We need to condense. All right, give 15 a try. Simplified and everything. What'd you do?
Well, you got to put it 2 to the power. 9.
Well, how do we know to divide? Subtraction is division. Done? Always check those at that point. That's done. Alrighty. Go after 16 if you haven't already. So far, everybody is not making the most common mistake that's made this one. I don't know how many times when I read this test I see log of y. Happens all the time. So division, right? And then you need to cancel, but you have to remember there's a 1 up there. And it's just, I don't know why, but generally the other 2 classes, it's always log of y. It's like you forget the ones up there. You guys did great with that. Ooh, 17. I'm going to need to move some stuff over here. Let's see, where's my slider? Should we do this one together, or do you have it? Do it together? Okay. So, I see parentheses. Just like order of operations, we should probably deal with that first. What does that do? Right here, what is this? Multiplication. Let's put that together. What on earth is that on here for? from these two right here. They both had that 1/2. That's why there were parentheses up there. Hey, both of these things need this 1/2. That multiplication came from a power. Now, that looks awkward because it is. We need to finish it up. What's 1/2 power? There it is. So condensed, that's what it would have looked like. And then we would have had to say, oh, look, those are both to the 1/2 power, and we would have gone through this whole process.
On to the next
All righty,
one. Move it along.
keep her going.
Grind them out. Grind them out. Oh.
Now, you can just use reverse logic from what we just did on this one. Give her a try. Ready? What'd you do first? No.
Split them all apart.
Split them all apart, yeah. And the big picture is we have division. Now, you guys are getting really good at this, so some of you are able to do all this stuff in one step and say logarithm base 2 of 4 plus logarithm base 2 of x cubed minus logarithm base 2 of y. In fact, some of you did the powers along the way too. So that 3 has to come down in front of just that term because it was only the x term that was going to be to the 3rd power. Because we're not done.
Oh, yeah. The line 2 and 4.
Is
2.
exactly.
Oh, I would have missed that one. I'm not going to.
Whenever we have a base that's evaluating just a number, we need to ask ourselves, is that something nice? That's a test writer thing. Or they say, oh, are they going to notice that if they snail shell this, 2 to the something is 4, hey, that's a 2. So slow down a little bit when you get to those. All right, 19. Since we did the condensed one, this probably will go a little faster. Another one where when you think you're done, there's probably one more thing you can simplify. So in steps, split them up. They don't both have that square root symbol, which means you have to split them up by that multiplication, which is addition. And then we have this 1/2 power for square roots that we would bring up front. Let me write it this way so everybody can see it. And again, here's the step people generally do.
I got it right. Yeah. I got it right too.
After doing 18, bam, right? There it is.
I had this for the X and all that. That ain't right. You gotta have that.
Now, that brings us to a really good point about test-taking strategies. If you still have that square root at this point, and you flip back to the problems you just did on condensed, you should be asking yourself, oh, wait a minute. These are supposed to come with square roots because when I work backwards with condensing, that's what I saw. And use that test taking strategy for condense and expand. All right, this next one really should be, no points for it because we're supposed to know how to do this at this point. But just in case, the big thing here is using the change of base formula because that's what the instructions say. You can't just give me an answer. Use the change of base formula to evaluate each expression using common logarithms. So you have to use LOG and round to 4 decimal places. So what do you do? Log 8 divided by log 3. That's the big one right there. Now, if you mess up somehow and punch it in wrong, obviously there's a point or so for getting the right thing here. Because it's 4 decimal places, remember. The test is not going to say that. Make sure you always round to it. You need to understand logarithms go 4 decimal places. So, what do we get? Everybody thinks they punched it in wrong? 1.8928. 4 decimal places. So far, so good?
Yeah.
All right, we'll switch gears. Bless you. Bless you. Graph. Some of you were asking about these yesterday in the review. So what do you do?
Snail shell.
You do? You do. We don't have an H and a K in this one. This is the parent function. So we are going to snail shell this.
Why did you
No. Oh, maybe I heard you right. Say it again.
3y
Oh,
equals X.
3 to the y equals x. Okay.
Oh, yeah.
I thought you said
I was
3y
thinking-
equals x.
Well, I was, but I was thinking that, but I said it.
Okay.
Thanks, Joe.
This is the parent. So we can jump right over here to our table. But what's unique about our table, everybody? Do we want lots of negatives? Don't need them. Those are the ones that are going to be the fractions. I know it says use at least 3 points for your table. 4 is definitely safe. So 3 to the negative 1. 3 to the 0. 3 to the first. 3 squared. Now that you had to do that backwards, don't graph backwards. That's always the risk with this.
Yeah, I did too.
You get used to it's always been x then y. Dashed? Doesn't need to be. We don't have an H in it. But graph asymptotes. What was that? X equals 0. So that helps us out with the domain, doesn't it? Did that mess with you for a second? Looking at your y's going, we use negatives. Those were our y's. Remember, it's just that inverse relationship. Range.
All real.
All rails. Now let's make sure we did everything they said to do because I didn't read the directions. Graph each function. Done. Showing the parent function and then the translation. Didn't have a translation. Graph the asymptotes. Bam. Right there. Make sure you use arrows on the asymptotes. Remember, even though it's a helper line, it's still a line. And then use at least 3 points for your table. Overachieve a little bit there. Got it. Making sense?
So you need divided thought. You need the
Super overachiever.
dotted asymptote line on it.
You do, because it said graph the asymptote.
You can't really see the line. It's over a black line.
Oh, graph polygon. Rather than that. You want to use the polygons for that? That would be cool. I would love that when I'm grading.
Oh,
Look
really?
at that,
Okay,
I
I'll
can
do it.
see it. It's It's standing
You know
out.
what it is for the next one? What?
Shh. Joe, I don't think you have a whisper button.
It's x equals -2.
So our parent is not the whole thing this time, right? So we think ahead because we don't want to forget it. Where are we going to shift this graph? 2 to the left. 2 to the left. All right, so our parent is going to come from y equals logarithm of x. There it is. Snail shell. What does it say?
N to the y.
What do you want to use?
-1, 0, 1, 2.
Just kidding. So what's 10 to the negative 1? 10 to the 0. But you know, that is so helpful because it tells you it is almost flat. So when you're graphing, you'll know, don't make it look like it's going to zip up. Really high. It's not. So 1/10, -1, 0, 1. Dash to dot. Yeah.
You said dashed or
Dashed or dotted. It's hard for me to do dashed up here with the smart board. It's easier. Did we move this?
Yeah, move it left.
So is the asymptote going to move?
Yes.
So we better not forget to graph that and put it on there. So where's it going to be at?
This one we don't know.
No, this one lines up. Different spot. What's the equation for that? Green line? X equals -2. All right, let's move our graph. And that one is, bless you, solid. Again, it almost needs to look flat, but it doesn't even look like it's still going up. This one kind of runs right over itself. That parent function. So what's our domain? It does. X's. Range. Did we do everything they asked? Graph each function, showing the parent's function, and the translation, graph asymptotes, use at least 3 points.
Oh my shot, guys.
Anything else? I mean, I can come up with extras of anything that we've done today. If there's anything that you're like, ooh, I'd like one more practice one of that. Now is the time.
The review like really long.
Yeah.
I didn't start it last long.
It's
So
gonna take you
it's
like.
gonna be hard.
You didn't start it last night?
Well, I was tired.
What was the number that you worked out for next week?
Oh, I remember.
Talk me through.
Back to 12, guys. Oh yeah, you gotta put ability in the snap.
And then it's grab the good old calculator and 4 decimals for this one.
Whoa. I grabbed.
That's check grade. Very cool.
Oh, is that like
No,
cosine graph or something?
it's just division. Very basic. Anything else? Got Alex. Which one? 33. Oh, I'm doing practice test. What are? Repeat.
Can we get our partners?
Yeah, you can have
Even better. I was just talking partners.
Okay, Allie just asked about one where, yeah, it's harder than the test. Because Allie, with that one, you're going to snail shell, you're going to have a quadratic, and you're going to have to use the quadratic formula to solve it. And that's, yeah. I mean, it's a great problem.